Chapter 10. This screencast will be 10.1, 10.2, so let's take a look at what we're working with for the screencast. Characteristics of gases: unlike liquids and solids, gases will expand to fill containers, which means that they can also be compressed. Liquids can be compressed only slightly, very little, which is how we got to like the science of hydraulics, because we used liquids then to transfer pressure from one place to another because it doesn't compress very well. They also have extremely low densities. That means liquids and solids have densities that are measured. I should say this: densities measured, that says densities, measured in grams per milliliter or grams per cubic centimeter. These two are the same, they're equal to each other, whereas gases tend to have densities measured in grams per liter. Okay, so that means the difference between milliliter and liter is about 1,000. So that means that the densities, the difference between liquids and solids, is that they are 1,000 times more, or you could say gases are 1,000 times less dense. Okay, so that's good to know. Moving on. So that means that we can measure something called pressure. Now, you can measure pressure with solids and liquids also, but for gases it's a little bit more of a theoretical concept than it is a very practical, and I don't mean practical, I mean because we don't see most gases, the idea of pressure from those gases are like lots of people think, oh, the air doesn't have mass and it doesn't have pressure. Well, actually it does. If you take the column of air that is above your head right now and measure the mass of that and the amount of force pushing down on you because of the mass of the air, you will see that there is something called atmospheric pressure. Okay, the pressure of the mass of the air above you is pushing down on you and in you like it's pushing from all directions, because that's the nature of the gas. So pressure equals the force divided by the area. Atmospheric pressure is the weight of air per unit area. You may see atmospheric pressure listed in, well, here, you'll see it next slide. So we're going to use pascals, except pascals are a very small unit because it's newtons per square meter, and per square meter is a very, it's a decent size area. So instead of units like newtons per square meter, which is a pascal, we're going to use kilopascals. So it actually, the average atmospheric condition is 101.3 kPa, and that equals our average atmospheric pressure, which is 1 atmosphere. So atmosphere is another pressure unit. Okay? So something else we use is called millimeters of mercury, which is also called torr. I know this seems to have gotten very complicated very quickly. So let me show you what we've got here. 760 millimeters of mercury, like a column of mercury, less than a meter tall, because 760 millimeters is like 76 centimeters, and 100 centimeters equals a meter. So it's less than a meter tall, but that's how much pressure the atmosphere has. So 760 millimeters of mercury is equal to 1 atmosphere, which is one of our pressures, and that also is equal to 101.3 not kilograms, kilopascals, so kPa, like that. Okay, so over here is a picture of the atmosphere pushing down on a pool of mercury, and here we took a column, we took a tube of mercury, filled it completely up, and then I inverted it and put it into the pool of mercury. And what happens is part of the mercury kind of slides down. This right, the H part, is from the pool on up to the very edge of the mercury, and this equals 1 atmosphere. We use mercury because it's very dense. If we use something that was not as dense as mercury, our column would have to be a lot higher to feel the difference. So here's something called a manometer. A manometer is a way to measure the pressure of gas. And one of the ways it does that is you have a vessel of gas right here, and then your manometer has a U-tube, two U-tubes, and this part right here is mercury, which is why they started using mercury, because it's a liquid and it's very dense. So we can measure the difference between the height of where it's the highest and where it's the lowest. So if we do something like this, the pressure of the gas, if the pressure of the gas is lower, pushing more on the mercury on the left-hand side than it is on the right-hand side, then it would be the pressure of the atmosphere plus the height of the gas. If it were reversed, and let me erase this, and this end ended up being up here and this end ended up being down here, then the pressure of the gas would be pressure of the atmosphere minus the height. Okay, it all depends on which side the pressure of the gas is on. Okay, standard pressure. The standard pressure, I've gone through this already a couple times. 1 atmosphere is labeled as 760 torr, and torr is the same thing as millimeters of mercury. It's just another way to say it. And 101.325 kilopascals, although we go to 101.3. Okay, that's the end of 10.2. So that's a really short screencast. You're welcome.